So we're just starting here with a little bit of practice, a coterminal. So 5 pi over 4. Where is that? If you were going to describe it, is it in quadrant 1, 2, 3, or 4? Number 3, okay. And what type of a triangle should I draw in quadrant 3? I mean, I have to draw a line that goes out here, right? What type of triangle is it going to be? 45, 45, 90, okay. And that means the sides are 1, 1, and the square root of 2. Unless you want to get fancy and make this the unit circle, in which case you could divide them all by what to make it the unit circle? Square root of 2. But let's not, because you don't need to. And then what's the most common mistake in circle trig, Caleb? Negative, negative. Okay, now I got my triangle set up, and that's the important angle. 2 names for that, Lucas. Give me one of them at least. Angle. Okay, good. You got the other one, Ashna? Starts with an R. Reference angle, good. Okay, so then cosine of it. Adjacent over hypotenuse, right? Negative 1 over root 2. What if that wasn't on the key? But there was a correct answer on the key. If you times it by root 2, like this, it'll be negative root 2 over 2. Would I take both? Yes, I'd take the blue one or I'd take the red one, either way. Okay, next coterminal. There's other places other things that stop there. Like you could have gone this way. Hoxton, what would that be? Negative 3 pi over 4, perfect. Or you could have gone all the way around again and then stopped there. That would have added how much to it? You went all the way around the circle, right? All right, give the person a chance to put their phone away and get back with us here before they would lose their phone. There you go. So we are going to go all the way around the circle once, and that means I'm going to add 2 pi, but I need a common denominator. Everybody figure that out and give me a final answer. Go for it. All right. Davis, what should I change the denominator to so I have a common denominator?
4.
So if I do that, what do I have to do?
Multiply the top of the 2 by 4.
All right, so then this becomes 8 and 5. Final answer? 13 pi over 4. Is there other ways to make coterminal angles? Yes. You can do it in negative and then add 2 pi if you want to. All right, next thing. A ton of kids had this one wrong. I'm going to see if you've got it down by now. I'm going to say that that's exactly 1 radian. That's a radian. You know how I would know it was a radian? If this was 8 and this was 8, and what else was 8? Yes? The arc length was 8. Okay, so I'm saying that's a radian. I want to know what would be the area of the green sector. I'm going to pause for a second while you figure out area of a sector of a circle, and that's 1 radian. So you're not going to use degrees over 360, are you? Because unless you have memorized what a radian is, it's going to be difficult for you to do degrees over 360. So then you should be able to do something over, instead of 360, what are we going to do to over? Yes?
Radians over 2 pi.
Radians over 2 pi. Very good. All right. I'll pause for a second. Is there any clarifying questions here? We're trying to find the area of the sector. Yes?
On the test, are you going to be given the formula?
You are given formulas, the same formulas they give you on top of the little quiz. And it's right here on the board if you want it. And I personally, though, think you should do radians over 2 pi, because it just makes sense. It's your part of the 2 pi times pi r squared. But could I cancel those pi's there? Yeah, I could. But I just want you to see how it's built. Instead of just having a formula that you don't know where it comes from, radians over 2 pi would give you kind of like degrees over 360. All right, I'm going to pause for a second. So let's give it units just so you can like maybe get a little bit better perspective. On the board up there, I'd say maybe the closest units that could be, it's certainly not 8 feet. Maybe it's 8 inches. Okay, 8 inches in each of these directions. Then the area would be in square inches. Okay. Do you get this is about 59 degrees? Do you remember that deal? It's not 60 degrees. A radian's about 60, but not 60. That's what we started this unit with. About 59. But that's not really important here. It's 1 radian over 2 pi times pi times the radius squared. The radius is 8. 8 squared is 64. And it's as simple as, let a few things cancel now. Cancel that, cancel that. 64 divided by 2 is 32. 32 what? Square inches. Any questions about that? Okay. Now that one, we had the arc length. We knew that was 8. So let's make another one that's similar, but this time I want the arc length. And I'm going to say, I've got an angle. What angle's about there by now? You should be getting pretty good at these. It's clearly not, it's got to be bigger than 90 and less than 180, but do it in radians. It could be construed as 3 pi over 4, but it's not. I'm going to say it's less than 3 pi over 4. So then what is it probably? 2 pi over 3. I agree. Okay, and let's make this 8 again. My question is, how big's that? And then, how long is its arc? 2 different questions. What's the arc length? If you forgot the arc length formula, be honest and raise your hand. All right, thank you for being honest. S equals theta times r, where 1 is the arc length. Sorry, 1 is the radius. This is the sarc. That's the arc length. 1 is the radius, and 1 is the radians. That'll give you the arc length. Again, my writing was messy, but you should know that that's where 2 pi over 3 is. So, the arc length will be the radians, 2 pi over 3 times the radius, which is 8. So it's that simple, 16 pi over 3. And if that doesn't feel like a length to you, it's probably just because your pi is making you think it's an angle, and it's not. It's just 3.14. And that pretty much cancels with the 3. I mean, they're close to each other. So it means the answer is close to 16, which kind of looks like it makes sense for this. Like it should be like twice as long as that 8. So, all right, and then the area, I always go with pi r squared because this is part of a circle, right? And then it's the radians, 2 pi over 3 over 2 pi, because that would be out of like 360. And that's the percentage of the circle that you have. And the radius here is 8. And so then this is 2 pi over 3 times 1 over 2 pi. Get what I did there? I made that into like over 1, and then I flipped and multiplied. And then it's times 64 pi. And then the pi's cancel, 2's cancel, and it's 64 pi over 3. And I'm pretty sure that doesn't simplify, but I could be wrong. Double checking, 6 plus 4 is 10, so 3 does not go into 64, because if I'd added those together and it was like 12, then 3 would have gone into it. So I think that's it. Raise your hand if you had those 2 answers right. Okay, cool. Then next step is, how about I am outside running, and would you picture for a second that I go 5 meters? Okay, and that's about 15 feet. How fast do you think I could do that? 5 meters. Do you think I could do that if I got up to speed, do you think I could do that in 1 second? Okay. Then can you change that to miles? Wait, no. Kilometers per hour. kph. You know what kilo means? You should memorize that one. 1,000. Therefore, kilometer, 1,000 meters. There's a few that you should memorize. Kilo, mega, what that means? Million. Giga, billion. So if I said a gigameter, it's a real thing. And the ones that are starting to become like a bigger deal is tera. Most of you guys have heard of a terabyte. You know that back when you were born, nobody had a terabyte drive. Just it was massive, way too big. Nobody would have that. But now it's common. Now even like a 2 terabyte drive is fairly common. So what goes next after tera? Peta. Very good. So they're always in sets of 1,000. So that means 1,000 terabytes would be a petabyte. That'll probably last you for a while. But, not kidding, when you're my age, they won't be talking about those anymore. They'll be too small. Okay, so did you know you're supposed to be multiplying this by meters on the bottom? How do I know it's meters on the bottom? Ashana. Yeah, it has to cancel the other meters. So then you'd be thinking about what's a fact you know about meters that'll help get us closer to kilometers per hour. And it's 1,000 meters is 1 kilometer. So then I can cancel my meters. And now I'm in kilometers per second. To get the seconds out of there, you multiply by seconds on the top. And what's a fact you know about seconds? Marcus. Mr. Marcus. Fact you know about seconds?
3,600.
Ooh, I thought you might do that. 3,600 seconds in 1 hour. You don't have to do that one. You could have done 60 and then another 60, but this is the fastest way. Sweet. Seconds cancels, and I go right to hours. I now have kilometers per hour, just like I wanted. All I got to do is that times that, and all of that, which is just 1,000, because the other ones are ones. And on the test, since we often don't have a calculator allowed, we would allow you to leave it like that, because don't really expect you to be able to crunch out complicated 3-digit, 4-digit multiplications. That's pretty nasty. So if you set it up right, you'd have been okay. Any questions? Okay. Then what else did we learn? Oh, so much stuff. You started learning like this is pi over, what do you think? Pi over 6. And so then you could say there's a whole bunch of other pi over 6s in the land. Would you please figure out what cosine of 10 pi over 6 is? And I know we wouldn't normally say 10 pi over 6, but maybe you can figure out what that would be. Or you can just count up to 10 pi over 6s, and you'll be in the same spot. And pause for a second. All right, this is where I get to 6 pi over 6, 7, 8, 9 pi over 6, 10 pi over 6. It's that one. I'll change the color of it. It's that one. So then I draw my triangle around it. And this is a 60, and this is a 30, and this is a 90, and then I know these. Oh yeah, I got this memorized. I always go across from the 30 and put a 1. And then across, well, then I do the hypotenuse and say 2, and this must be square root of 3. And then I'm going to put in a negative only on this one. Cool. Then cosine is adjacent over hypotenuse. Adjacent, hypotenuse, 1/2. Raise your hand if you had 1/2 for that one. Cool. Any questions? Okay. Then, what if I had asked you for the cosecant? Which one does that go with again? Because if you remember that, it's going to be easy. But if you don't remember that, you're cooked. cosecant. I would try to remember it this way. Sine, cosine, tangent. And then they each have a sister function. Do you remember me saying that S goes with C and C goes with S? So sine goes with a C, and well, it's certainly not cosine. It's not the inverse, or the reciprocal of cosine, so it must be cosecant, and sine goes with cosecant. So then, let's just finish this. This would be secant. S goes with C, and C goes with S. See, here's a C, and here's an S. And then tangent goes with cotangent. Okay, so now, if I was going to do cosecant, I wouldn't. I would start with changing the problem to sine, just because I like it better. And I do sine of 10 pi over 6, and it's not the same thing, but I gotta do a quick 1 over to remind myself. I'm gonna get my answer, and then I'm gonna put 1 over it. So sine is gonna be opposite over hypotenuse, which would be negative root 3 over 2, but then it's 1 over that, which makes it flip. 2 over root 3, the negative can go anywhere, it doesn't really matter, but I'll call it negative 2 over root 3. Raise your hand if you had that one right. Cool. Okay, so then there's that kind where you have a unknown side, like it's just x. Or in this case, I'm going to say it's x plus 1. Sine of some angle is x plus 1. Find cosine of the angle. It's all about drawing triangles, so where should I draw the kind with a variable? Because it could be negative or it could not be negative, so it could be in any quadrant, so I told you to first quadrant. Always make your triangles short and fat. Don't make them long and skinny like a 30, 60, 90, because that will confuse you at some point, because you'll be like, but this angle's really small, and there can't be a 60 there. Okay, Stockham, when I said sine was x plus 1, how did I really give you two sides? I gave you the opposite and the hypotenuse, so how did I give you two sides?
I got no idea.
All right, I'll give you a hint. Put this over 1. So now I've got two sides.
Yeah, x plus 1 is the opposite.
Yep. And the hypotenuse is?
1.
Yes. Now everybody take a second and figure out this third side. Question. Louder. Ooh, I think you got me here. I think you got me here. She just said that the hypotenuse has to be bigger than the other one, right? Except, couldn't x be negative? There's no rule that says x can't be negative. So I think I got you back. But it was a good thought. So we can do that because x could be negative. In fact, x will have to be negative to make this work. But all right, have you figured out this little system where you square both of these and you put them under here? And we know which one's bigger. One is bigger. Okay, so we're going to take 1 and we're going to square it. And then since this is not the biggest side, we're going to go minus x plus 1 squared. Now this is where a little misconception from a million years ago would burn a lot of people. A lot of people just go, oh, so this is really x squared plus 1. And then the plus 1 and the negative will distribute, so then the x squared is just alone under there because the 1 and the negative 1 will cancel each other out. Nope. Because this really is x squared plus 2x plus 1. All right, so let's actually simplify this down. Square root of 1 minus x squared, and I got to be careful with that negative. I got to really distribute it to everything, right? Plus 2x plus 1. And then when I distribute that negative, I got 1 minus x squared minus 2x minus 1. And the 1 minus 1 will be gone, but I got square root of negative x squared minus 2x. Don't ever try to simplify it down and get the square root out of there when there's variables. Just leave it underneath the root. Ever's a big word, but for this unit anyway, don't try to simplify this any further. Okay, so that's my adjacent side, and cosine is adjacent over hypotenuse, so there it is. Square root of negative x squared minus 2x over hypotenuse is 1. And since the hypotenuse is 1, this is just gone. Okay. That's pretty much the review of the unit. So I want to do something fun. We don't do many just like games in here, but one of my colleagues, Mrs. Roach, found a quizzes which looked pretty good, and she's going to use that today. So I am going to try it too. So go into Schoology right now, and your homework is going to be a worksheet. You'll be able to find it by the time you get this video, everybody. You just look in the folder for today and you'll see what the worksheet is. But, and there's also a little Schoology quiz. I'm deciding whether to sign that today or maybe that'll just be Monday. But whatever's in the quiz, the folder for today, whatever is there, that's your homework. And the rest of the hour, we're going to play this little quiz, and then the kids will work on the homework. So that's all I have for the video for today.